We all use salt in our daily lives, starting from the salt on a bread roll to the salt in the dishwasher. In fact, there's salt in almost all of the things that we use in our day-to-day life. Let's have a look at all the things that we would miss without salt. For example, colour, or even glass, paper, leather, PVC, plastic, and that means laminate. These are all made using those white crystals from the earth.
A lot of products we use every day are based on salt and its components. It is a remarkable crystal, the corners of which form exact right angles. Cooking salt, as we know it, consists of two elements, sodium and chlorine. In a salt crystal, the sodium ion has a positive and the chlorine ion a negative charge. These charges hold salt together in its grid form. But what exactly are these two elements which form this perfect bond? Firstly, they are very rare. In nature, we almost never encounter them alone, but mainly in this form as salt crystals. Sodium is a soft metal. Chlorine, in turn, a colorless gas. What connects them is their extreme reactivity. A rose which is held in chlorine bleaches almost completely. And anyone wanting to experience what happens to the metal sodium when it is put in normal water needs protective wear. When these two elements, sodium and chlorine, meet, they react immediately. And once bonded, they are almost inseparable. Even when salt dissolves in water, the two substances only separate temporarily. The crystal structure does break down temporarily through the doubly charged, that is, dipolar, water molecules. However, as soon as the water evaporates, the salt immediately crystallizes again.
So, if sodium and chlorine are almost inseparable, then I ask myself how the chlorine here, for example, gets into the swimming pool. Because it can't have dissolved. It doesn't taste very salty to me.
Sodium and chlorine are separated best through electrolysis. The sodium chloride that has dissolved in water is forced to separate back into its components by introducing a lot of electrical energy. In our example, this occurs through diaphragm electrolysis, in which a separating wall ensures that the end products do not recombine. Otherwise, chlorine and hydrogen would form a highly explosive oxyhydrogen gas. At the end of this process, you are left with sodium hydroxide, hydrogen, and chlorine. The two other main types of electrolysis used in industry today are amalgam and membrane electrolysis. Countless manufactured products are based on cooking salt or its components, sodium and chlorine. When wood chips, for example, are heated up with sodium hydroxide, the result is cellulose, the first step in the manufacture of paper. Mixing fat with sodium hydroxide in turn results in soap. Sodium hydroxide in general is a good acid neutralizer.
So we now know about sodium, but chlorine hasn't been talked about much yet.
Chlorine, of course, isn't only used in swimming pools. It is also used for the production of many plastics, for example, to make this toy fire engine. But real firemen also use an extinguishing agent based on chlorine, for example, to put out metal fires. Chlorine is processed into colors, also into the very sustainable epoxy resins which are used for varnishing ships and cars. Soda also results from processing salt. It is necessary for making many colouring agents as well as glass. With soda, sulphur can be removed from crude iron. It is also a standard ingredient in most washing powders and cleaning products. And without sodium carbonate, better known as baking soda, this would be dry and hard. Extinguishing agents are also made from sodium carbonate, as well as medicines. Salt is crucial for numerous products.
Well, so if there was no salt at all, then most industry would have trouble functioning. As well as our cooking salt, sodium chloride, there are other types of salt. A very valuable type is, for example, potassium chloride. It also tastes salty, and it's also extracted from mines, in the German potash mines. If you take this energy drink, it must contain potassium. Without it, not a single muscle can work properly. This child here doesn't do any sport yet, but still there are minerals added to his porridge. Potassium is one of the most important ones. That's why our pets and livestock also have potassium added to their feed. Potash salts are just as indispensable for industry. These plasterboards are known to anyone into DIY. What people don't often know is that potash salt has been used here to solidify the plaster. And these screws here would rust pretty quickly if they weren't protected by this shining layer of zinc. The screws have to be immersed in a bath, and the potash salt enables the zinc to cover the screws permanently. This procedure is called galvanizing. It wouldn't be possible without salt. These shining aluminium rims also couldn't be made without the aid of potash salt. There are numerous other products which are manufactured from or with salts, like, for example, this white paint here. If I were to list all of them here, I think I'd never get this job done.